How you going, Year 10? Today we've got a video looking at Venn diagrams and two-way tables. This is part of our probability unit. The way this video is going to work is I'm going to explain some concepts. I'm going to do some example questions, and then I'm actually going to ask you to pause the video and see if you can complete the questions yourself before you then unpause and then check your answers by watching the rest of the video. I think that would be the best way to get the most out of these videos, to actually test your understanding and then confirm it or correct it. And that's how your memory works. So if you want to sort of learn this stuff and remember it long term, I recommend you listen and then pause when you're asked to do the questions and then unpause it. All right, let's get underway. So when we're thinking about Venn diagrams and two-way tables, we have to understand conditional statements. So conditional statements are things like when you say like and, or, both, only, those kind of things. And so we're looking at an example here. Let's say we were to do a survey of our class asking the question, do you like soccer or rugby? And let's say in this survey, you could answer both or you could answer neither. All of those were possible as well. Now, if I wanted to know how many people liked only soccer, I actually need to be careful because I need to find all the people who ticked soccer on the survey, saying they liked soccer, but I don't want to include anyone who ticked soccer and rugby. Okay, so only means you're only looking at the people who only ticked that part, and don't include anyone who ticked multiple things. Okay, now if I wanted to find out how many people liked soccer, that would actually be a different number, because it would include all of those who ticked the soccer thing, and it doesn't matter whether or not they tick the rugby thing. So the difference between only soccer and just like soccer is whether or not it includes those who ticked other things as well. So you just got to be careful. It's not necessarily as straightforward as you might initially expect. And if I wanted to know how many people liked both, I would obviously need to find out how many people ticked both soccer and rugby. And then liked neither would be the ones who didn't tick any of them. Okay, and then obviously the other option would be only rugby, those who ticked rugby but didn't tick soccer. So you can see we need to be careful when we're looking at those different categories. And what Venn diagrams and two-way tables are a way of visually representing those different options, okay? Whether or not people include, whether they like just one thing, whether they like both things, whether there's overlap there or not. So let's look at this first example of a Venn diagram. So the Venn diagram represents number of students. So there are 30 students in a class who plays tennis and who plays soccer. And we need to calculate the probability that a student chosen at random from the class. Okay, so we've got this survey data, and now we're going to use that. We've sort of worked out the relative frequency. We're going to use that to approximate, to estimate the probability of finding a student. So if we want to know how many people play tennis, we've actually got to be careful. It would be, when we look at this Venn diagram, we might think 7 would be the correct answer. However, that is the people who play only tennis. We also need to include the overlap of that tennis circle with the soccer circle. Okay, because there are 3 people who play both tennis and soccer represented by that space in between the 2 circles there. So when we do part A, those who play tennis, it's actually going to be 7 plus 3. Okay, those who play only tennis plus those who play tennis and soccer will be the total number of people who play tennis. And it's going to be a probability, so it needs to be a fraction out of 30 because the total number in the class is 30. Okay, now the number of people who do not play tennis is going to be all of the other people in the class. So 10 people play tennis, okay, and we can think of this as a complement. You may have heard that word last year doing probability. The complement is just the opposite, and we can calculate that as 1 minus the event. Or you could just think of it, well, if 10 people play tennis, then those who don't play tennis, it's going to be 20, okay? So 20 out of 30 will be those who do not play tennis. Now, the other way we could work that out is we could work out the people who play only soccer or who play neither and add those together. So 11 plus 9 would also give us 20 out of 30. Okay, part C, plays tennis, but not soccer. And in this example, we're going to use that 7 number. We don't include the overlap score. So this one will just be 7 out of 30, be the probability of finding someone who plays tennis but not soccer. All right, I'm going to ask you to pause the video and see if you can finish off D, E, F, and G based on the logic that you've seen so far. Once you've done that, unpause the video and check how you've gone. All right, let's continue. So part D, plays neither tennis nor soccer. That's going to be the number that's outside of both of the circles. So that 9 down the bottom. So 9 out of 30 would be the probability of that. Plays both tennis and soccer. Okay, for this one, it needs to be both in the tennis circle and in the soccer circle. Okay, so it's going to be 3 out of 30. Has to be in both. And then plays tennis or soccer or both. So this one, the or statement means we add all of the things that fulfill one of those criteria. So plays tennis or soccer or both. So we're going to add the only tennis, we're going to add the only soccer, and we're going to add the both categories all together. So 7 plus 3 plus 11 gives us 21. And then plays tennis or soccer, but not both. So in this case, we don't include the 3. We just go 7 plus 11, which will give us 18 over 30. Okay, so once we get the hang of it, not too tricky, we just need to be careful that we're reading it and we're thinking about which categories belong here. Do I need to include the overlap? Do I not include the overlap? Do I need to add things together? Those are the questions that you're asking when you're trying to work out and interpret a Venn diagram. All right, now a two-way table is a similar thing. It's a different way of visually representing overlapping categories. So we have 2 different features here. We have gender in this example, and we also have left and right-handed. And we've done a survey to see who fits in which categories. And so clearly each person in the survey belongs to either a gender here or is left or right-handed in this particular example. What is the probability that a student chosen at random from this class? So what we need to do, again, we need to work out what the total number is when we're doing probabilities. So we look at this bottom right-hand thing here. That's all of the categories added together, which adds up to 30. So you can see if you add the male plus the female, you get 16 plus 14, which is 30. If we add the left-handed and right-handed, that also adds to 30. We don't have 60 people because everyone is, we're measuring those 2 categories at once. So we have 30 people in total. Okay, so what's the probability that chosen that the random person from the class is female? What we need to do is we need to look at the total column. So this column over here is the total for male and females. This row down here is the total for left-handed and right-handed. So this, say, the number 2 represents those who are male and left-handed. The 14 represents those who are male and right-handed. Okay. So if we're looking for those who are female, then we're looking for the total number of females, which is going to be this 14. So it's going to be 14 out of 30 in this instance here. Okay, B for left-handed, we want to include the total number of left-handed people. So it's going to be this bottom of that column there, which is going to be 3 out of 30. Okay, not left-handed, okay, in this instance is basically just right-handed. If there was another category like ambidextrous or something like that, then we would have to include that as well. But in this case, it's just either left-handed or right-handed. So it's going to be 27 out of 30. Okay, male and right-handed means we're including the cell that is in both of those categories. So it's going to be the 14 one. So you see how that works? That cell represents those who are both in the right-handed category and in the male category. So 14 here means that you have both. So that and statement means you have to be in both for that one there. All right, I'm going to ask you to pause the video and then have a go at the rest of those questions there. And when you've done that, unpause it. Okay, so for part E, male or right-handed or both. Okay, we've got to be really careful here that we don't accidentally double count some numbers. Okay, so all of the male people, okay, is 16. Now we don't want to double count those who are male and right-handed because we've already counted them when we got 16 males. So what we need to do is we just need to add the female right-handed category. So to fulfill those criteria, you're either male or you're female and right-handed. Okay, because we don't want to double count the male right-handers. So it's going to be 16 males plus 13 female right-handed people, which will give us 29 out of 30. So we did the total number for the males, which is 16, and then those who are female and right-handed, which is here, which is 13. Out of those together, we've got 29. For F, male or right-handed, but not both, okay, means that we've got to include the males who are not right-handed. So the two males that are left-handed, and then we're going to include the females who are right-handed. Okay, so it's going to be 2 plus 13, which gives us 15 out of 30. So that's really tricky about which categories, which numbers you're including. You're including all the male ones, but not including the right-handed males, so just the left-handed males. And you're including all the right-handed people, but not the male ones, so just the female right-handed people. So 2 plus 13 is 15. For part G, neither male nor right-handed. Okay, so it's going to be the females, okay, who aren't right-handed, so the left-handed females. So it's just 1 out of 30. And then right-handed but not male is going to be the female right-handed people, which is just going to be 13 out of 30. So when you're doing these questions, you don't want to rush them. You want to read the question carefully, and you want to check which one of these cells do I need to include. Am I using the total? Am I using just one of the cells? Am I adding two cells together? Which two cells do I need to make sure I don't double count? Which cells do I need to not include? Those are the questions that you need to ask yourself and then find your final answer there. If you've had any issues with this, you can just rewind and watch this again, and hopefully that will make sense. Good luck with the textbook and the maths-based questions, and I'll see you later.